Hola, this is Miss Mo. We're still on 5.1. This video is about, we're still finding equations. We're still finding limits of equations, but what we're about to do gives us a zero in the denominator of a fraction, and then that causes us to do other stuff. So far, all four of these examples, all we did was just plug in the little number after the X and the arrow. That's all we did. But it says this is your limit, which all four of these were our limits, unless you get a zero in the denominator. If you get a zero in the denominator, then factor, cancel, and okay, that's too much. Let's just start with this. Okay, let's look over here at this example, x plus 6 squared. Okay, so if I try and plug in that -6, let's see what happens. On the top, we get -6 plus 6 squared. On the bottom, we get -6, use parentheses, squared minus 36. And if I do that, I think I get 0 on top and 0 on bottom. And this 0 on bottom is really bad in math. In math, a 0 on the bottom of a fraction means the world is over. I mean, it's horrible. It's a horrible thing. So anytime you get a 0 in the denominator, you have to say, wait a minute, is there something else I could do? And there is something else I can do. I can factor. So let's factor this. This top, x plus 6 squared, that means there's two x plus 6's beside each other. Squared means it beside each other. Okay, x squared minus 6, if I try and factor that, that's a difference of two squares. I think we did it on this very first page of notes, where a difference of two squares is the same thing times the same thing, but one has a minus and one has a plus. Okay, so for us, this denominator, it's a difference of squares because there's a minus and there's a tiny 2 in there. And there's two things, like x squared and 36, that's two things. Okay. Whereas over here on this top, we have 3 things, or 3 terms. Okay, anyway, so this bottom is a difference of squares, so I'm going to go ahead and draw 2 sets of parentheses, one with a minus, one with a plus, and we have to multiply the same thing by the same thing. So, what multiplies with what to give you x squared? Well, x and x, and those are the same thing. What multiplies with what to give you 36? 18 and 2? No, we have to have the same two numbers. So the same two numbers that multiply to a 36 are 6 and 6. Okay, so let's look over here at our steps again. It says this is your limit unless you get a 0. Poop, we got a 0 in the bottom. That's bad. So we have to factor. We did it. Now it's time to cancel. Let's go. This x plus 6 on the bottom and the x plus 6 on the top, they can cancel a pair at a time. And then let's write down what we have left over. We have x plus 6 on top, x minus 6 on bottom. And then now let's go ahead and bring down this limit x approaches -6 and do the whole thing again. So step 2 said if you got a 0 in the denominator, factor, did it, cancel, did it, plug in your x value again. Okay, let's go. So now I'm going to plug in my x value again. On the top, I'm going to have -6 plus 6 over the bottom, -6 minus 6. And I think this time it gives you 0 over -12. And that's okay. That 12 on the bottom is bueno. We won it. That means good. Bueno means good. Okay, anyway. So we do not want zeros on the bottom. So here we have a 12 on the bottom. Woohoo! So let's see. What is 0 divided by -12? Oh, it's 0. Okay. So my limit is 0. And you might be thinking, well, isn't that what the heck 0 divided by 0 is? I don't know. Let's see. At the very beginning, we said 0 divided by 0. Oh, error. It's called does not exist. So, if you have 0 over a number, that's beautiful. You can totally have that. Great idea. If you have 0 on the bottom, boo-boo. Okay, let's look at this example on the left. If I plug in 0 into the bottom, let's see. My bad. If I plug in what x approaches into the bottom. So x approaches 6. So if I were to plug that in the bottom, 6 minus 6 is 0. Oh no. Yeah. Okay, so I'll write this out for you. If I were to plug in 6, as in replace all the x's with 6, I would get a 0 on the bottom. Who cares what the top is, but the bottom's 0. And when the bottom is 0, that's boo-boo. That's really bad, okay? So I can't stop here. I have to try something else. So now I'm gonna try and factor. And this is the front page, the very right side of the front page of notes, where we tried to take a GCF out. So let's see here. Let's try and factor this top. The bottom will stay the same, but the top we need to break it up into two things that multiply together. So it's kind of like the difference of squares. We can start it off that way. What multiplies with what to give you x squared? Well, x and x. Great. Okay, now since this is a trinomial, it's a little different. We're going to figure out what two numbers multiply to 18 and add to -3. So, again, multiply, I'll write it up here, multiply to -18 and add to the middle number, -3. So let's see here, things that multiply to 18, 9 and 2. 9 times 2 multiplies to 18, but if I try and add 9 and 2, I get 11. Or maybe if I make one of them negative, I still don't get that 3 that I wanted. So 9 and 2 are out. Let's try 6 and 3. 6 and 3 multiply to 18, but they have to add to a -3. So which one of these has to be negative so that we add it to a -3? Either this 6 or this 3. So let's try it in our calculator. Let's see, -6 plus 3, that's where the 6 is negative, and we get a -3. Hey, that's what I wanted. Or if I tried 6 plus -3, where the 3 is negative, that's not what I wanted. So I'm going to use the pair of numbers that gave me adding to -3. So -6 and +3. So let's write that down. -6 +3. All right, so we got a 0 on the denominator. It was bad. We factored it. That was also kind of bad. We cankle. Okay, let's cankle. Goodbye, x minus 6's. Woohoo! So what do we have left over? All we have left over are x plus 3. And then now it says plug in your x value again. Remember over here, after we factored and canceled, we just plugged in this x approaches number all over again? That's what we're going to do. So for us, x approaches 6 right down here. So I'm going to plug in a 6 to this x. 6 plus 3, 9. Bam! Okay, yeah. Woohoo! Okay, so the whole point of this was you plug in the number, and if you get a 0 on the bottom, you try and factor and cancel. After that, if it still doesn't work, we'll plug it in our calculator, but I'll show you that in the next section. Okay, this one says how to find a function value from an equation. So the way function values work is it'll say f of a number. Like for example, this says f of 0. And let's go ahead and find a couple others. Let's say f of -2. And how about f of 3? Okay. So usually we see something that looks like f of x. That's what we usually see. So that means that all these numbers in the parentheses are my x's. This -2 in my parentheses is an x. And it's just asking us, what's your y value? Okay, so how do you find a y value? It's the exact same thing we've been doing, only they just use different symbols. So instead of using limit, they just say this f parentheses thing. So we're gonna write down the y value. So this says for the piecewise. So which one of these examples was that piecewise? It was that one in pieces right here. Yeah, okay. And we have to find out which piece of the equation we're going to use. Well, let's look. For this first sucker, it says f parentheses -2. Well, -2 is to the left. Or it's that x less than 0 up here. See how it says x less than 0? And that means all the numbers to the left. Well, -2 is to the left of 0. So it matches this x less than 0 requirement. So that means we're going to plug in -2 into the first equation. 9 plus a -2, and I think that gives you 7. So for the x value of -2, my y value is 7. So it's just like when we were finding limits, as in I gave you the x value next to this little arrow, and then we wrote down the y value by plugging it in. The only thing different is it looks different. Okay, let's look at this f of 0. So we have to figure out which of these alligators 0 matches. Well, let's think about this. It doesn't really match left or right, but if you remember, this little line underneath that alligator means equal to 0. So this second equation is for anything to the right or equal to 0. So for us, we have f of 0. So 0 is not left, it's not right, but it is equal to 0. So we're going to use this second equation because of that little equal to sign right there. So let's use the second equation. The second equation says 9 minus x, or 9 minus 0, and that's just 9. And hey, remember earlier up here when we said, hey, what's the limit of 0 just straight on? And remember, it was 9, as in the x value was 0 and the y value was 9. Look here, the x value in the parentheses is 0, the y value is 9. So it's the same thing we've been doing, just written a different way. Okay, let's look at this 3. We have to figure out whether 3 is to the left of 0 or to the right of 0. It's to the right. So we're going to use this second equation of 9 minus x. So we're going to have 9 minus 0, and that's equal to 9 again. So for this first sucker, we use the first equation because -2 was to the left of this 0, or -2 was less than 0. For these two other suckers, we use the bottom equation because 0 and 3 are greater than or equal to 0.